20 into 20 centimeter, 20 into 10 centimeter, or 10 into 10 centimeter. It may be uh, 10 into 5 centimeter, etc. But these are the standard sizes of chromatoplates. Now we have the selection criteria of stationary phase, that how to select our stationary phase for our TLC. So we have to check the nature of analyte, while it is organic, inorganic, inert, non-inert, which type of analyte we are going to use. Then the second is the reactivity of the sample with the stationary phase, whether the sample is very reactive with our stationary phase, non-reactive, which type of RF value it will gonna give us, or it may give a high RF value or a low RF values. Then there are the characteristic of the compounds. We have to study all the characteristic of the compounds, then we have to select it stationary phase. The solubility of the sample, whether the sample is soluble or insoluble to the stationary phase. Now in this TLC or in Hall chromatography, we have two types of adsorbents or the stationary phases, that are inorganic adsorbents and organic adsorbents. In inorganic adsorbents, we have silica, alumina, magnesia and silicate. Silica gel having formula of SiO2. This is acidic in nature just because of the selenol group present in their structure. It have the arrange the particle size of silica gel is of 15 micrometer, while the size range is 5 to 40 micrometer. The selenol group have three types of the silica gel have three types of selenol groups: free selenol, vicinal selenol and geminal selenol. As this is the formula, and we have look over here, this one, the very terminal silicon having hydroxyl group is our free selenol group, and this one is our vicinal, and the last one having two hydroxyl group, this is our geminal selenol. The most commonly used stationary phase is TLC, and it can be used for the separation of amino acids, methyl alcohols, alkalides, essential oils, steroids, etc. CH3 oil. The next inorganic adsorbent is alumina. Al2O3, commonly used as a stationary phase for the TLC. It is prepared by the calcination of aluminum hydroxide at 500 degrees centigrade. Alumina may be neutral, acidic or basic. As we have three types of alumina, acidic have O4 and it is the neutral alumina. Then the basic is O2, that is composed of alkaline compounds. And the neutral alumina is prepared by treating alumina with distilled water for 24 hours, and it is used for the separation of alkaline bonded compounds. Neutral alumina is used for the separation of alkali bonded compounds, and acidic alumina is prepared by the treating of alumina with acid for 24 hours and is used for a neutral and acidic compound. The basic alumina is prepared by the treating of alumina with base for 24 hours and is used for the separation of basic compounds. Then we have calcium magnesium silicate, and this is used for the separation of sugars. That was all inorganic. Now organic adsorbent. Organic adsorbent are the cellulose and charcoal. The cellulose is used in the TLC and more faster than the paper chromatography, used in partition chromatography, also in ion exchange chromatography. The next one is charcoal, and it have more absorbing capacity. Charcoal have more highest absorbing capacity than all other adsorbent, and as it is used for the separation of aromatic compounds. Now this is the first one step for the for the TLC, and that is the preparation of chromatoplates. There are different methods used for the preparation of chromatoplates for spreading the adsorbent on the chromatoplate. The first one is the dipping method. In the dipping method, this is the usual and common procedure to place the microscopic slide together and to make a double thickness of a glass and dip the two sides together into the slurry, being careful to the touching the slides at one end only, where they are held between the thumb and the forefinger. We have to hold these plates between our two finger, the thumb and the forefinger, and dip in the slurry. The two slides are then withdrawn slowly and held in a vertical manner for a minute or a draw of excess of adsorbent and to dry up. We have to dip that and to make it out and place vertical in a vertical manner and to draw it, or we have to keep it for a while to dry for the excess of adsorbent. When perfectly dry, the slides are separated from plates and are now ready for the preparation of a chromatograph. This was the first one type for the preparation of chromatoplate. Second one method is the spreading method. In this technique, several glass plates are attached to a support with the help of adhesive tape, and a slurry or adsorbent and is placed in the plate and then spread with a glass rod on the other plate. Another clean glass rod then rolled over the plates so as obtain smooth coating on the plate that help the dry and used for the separation. This one is also a simple technique, and spreading as the name indicate that the slurry is spread evenly on the plate. The third one is the pouring methods. The glass plate can be also be coated with adsorbent by the pouring methods. In this technique, the slurry is evenly distributed on the glass plate by slightly tapping the plate 2 and 4. In 2 and 4 position, we have to move the plate and the slurry is going to spread all over evenly. Without touching the edges, the chromatoplate is then dried. When the slurry is evenly distributed, then we have to keep it in the open atmosphere to dry it. The next one method for the preparation of chromatoplate is the spraying method. Simple method is spraying method, and the chromatoplate are be prepared by the spraying the adsorbent with the help of spray gun using an air pot of about 1.0 psi. Clear? Then we have the another method by using of a mechanical spreading devices. In order to obtain the uniform layer, mechanical spreading device are also used to separate up the adsorbent on the chromatoplate, but the mostly used method among these is the dipping method. Now is how to prepare a slurry for a TLC plate. We have to take out some higher amount of adsorbent in a bottle and add water into it, or either acid or any basic buffer according to our requirement. Then we have to shake it until a thick homogeneous slurry has been formed, and the slurry should not be too much thick and not too thin. The slurry is formed of any adsorbent, water and acid, or base or buffer. This is the preparation of slurry for our TLC plate. The more the slurry is perfect, the more the result will be perfect. Now we have the second step, that is the activation of chromatoplates. In this chromatoplate we have to remove the water or other polar solutes that affect our development of the chromatography. By adsorbing the chromatography, this should be removed from the chromatoplates. This is known as activation. The process in which we have removed the polar solutes and the water from our chromatoplate is known as activation of chromatoplate. In this, the adsorbent can be activated by placing this plate in an oven at 100 to 105 degrees centigrade for about 80 minutes. Adsorbent take got started when we place our plate in an oven having 100 to 105 degrees centigrade for about 80 minutes. When plates are coated with the silica gel cellulose, the dry chromatoplates are exposed to atmosphere for a time because it contains amount of moisture is essential for the satisfactory solutions, and this process is known as deactivation. Activation when the water is removed, and the deactivation when it is uh, kept in an open atmosphere. Now the third step is the selection of a solvent. In this we have to select the metal and clean solvent. Then it should be of a particle free and of the highest purity, as the solvent should be particle free, having a uniform composition. The solvent recommended are chemically inert with the sample in the stationary phase, may be polar or non-polar. Then the high polar solvent should be avoided because the adhesive capacity of stationary phase both will have the more adhesive capacity, and then it will damage our results. The most commonly used solvents are the water, toluene, xylene, methanol, acetic acid, methyl acetate, acetone, benzene, chloroform, etc. Then if we are using high polar solvents, then we should have to use acidifiers or basifiers to increase or decrease the polarity of the solvents. Then a commonly used acidifier is the formic acid or the acetic acid, while the ammonia is used as the basifiers in the TLC. Now the fourth one step is sample application, and how to apply our sample on the TLC plate. Using a fine capillary tube or a micropipette, the sample are applied in the sample small spot to the baseline about 2.5 cm from the edge of the plate at the least 1 cm apart. Carefully should be taken not to allow the large drop on the scene to be transferred to a coated plate. The next one is not more than 1 ml should be applied to each spot, and the solvent is evaporated between the application by the directing a stream of warm dew from a hair dryer for a perfect result. If the compounds are the thermally stable cold or should be used, and commonly application are also available to apply a very narrow uniform streak of spot along the length of the chromatoplates. The chromatoplate is now ready to develop. So this one was the fourth step, how to apply our sample to the TLC plate. In this we have studied that the baseline should be